All right, today we're going to do some coding in Rust. So here's what we're going to take a look at. We are going to build a custom interface around the EVTX Rust library, okay? And there's a couple things. So the Rust EVTX library comes with a tool, EVTX dump. And we want to add some additional functionality, or we want to do some things a little bit different. So we want to utilize the main library, but we don't want to use the interface that ships with it. So that's what we're going to code up real quick. We're going to take a look at two other libraries. The first one is CLAP, command line argument parser for Rust. I haven't used too many other command line parsing utilities or libraries in Rust yet, but I absolutely love this one. So unless I really find something that blows me away, I think I'll just keep using this one. So this is going to do things like allow us kind of define arguments, parameters that we want to take in from the user, parse them out, and then be able to use them within our tool. The second one I want to take a look at is this ignore crate. It is a way for you to be able to walk folders in parallel. So EVTX library is already fast, but if we want to go ahead and add like multi-processing on a per file basis, this is a really good crate to know about. So might as well go ahead and use it. And then of course we'll be taking a look at this crate. Some of the things I want to point out if you're new to this Rust thing, documentation is amazing in Rust. They've done a really good job of just standardizing where you go for documentation. And so I'll be kind of showing how I go about looking up these structures and how to use them, but I think you're going to like it. I can tell you that compared to Python documentation, Rust documentation is like mind-blowing because, well, Python doesn't even really have that much documentation in the first place when you go to use other people's libraries. So because they've standardized it, it's just so easy to know what you're working with. And not only that, but know which version of which libraries you want to use as well. With that being said, let's go ahead and jump into it. Let's create a new cargo package. So if you're not familiar with Rust, there's plenty of libraries on kind of how to start a new project. We're going to say cargo new, and I'm going to say --lib. And this is something I like doing. I kind of, anytime I create a new tool or something to play around with in Rust, I always create it as a new, like a library structure over just a single binary structure. It would be more like a single binary if I just said cargo new. But if I say lib, it's going to set it up more in a library context. And for me, that's easier because it makes it easier for me to just add unit tests and be a little bit more picky about how I set my project structure up, which is how I like it. So we're going to create a new tool. We're going to call this one probably yet another EVTX tool. So yet. And we'll go ahead and create that. All right, so then let's go ahead and open this up in code. Yes, I trust. All right, so now we have pretty much a blank state to start with. Like I said, it initialized this as a library. I'm just going to get rid of the boiler code here. All right, so if you're new to Rust, project structure is everything when you're first starting off. In your source folder, let's create a new folder called bin. And then what we're going to do is we're going to create a new file where this is going to be our binary. So we'll just call it yet .rs. So yet another event log parser or tool. All right. So now we've got the file we want. Let's do this. I'm using, by the way, Rust Analyzer is a great plugin. That's what I'm going with right now. It's pretty easy. So if we said something like function main, and then we'll say just like print, we'll say print line is a macro. I'm going to say hello. So now let's go to open up a terminal real quick. We say cargo build release. So I'm compiling in release mode, and then I can say target release. Yeah. All right. So that's just going to say hello. Cool. And that's the basics of it. So now, we just compiled a binary that we can use. All right. But that's useless for us. So let's make it useful. Like I said earlier, we're going to start off with the clap to create our kind of interface, create our parameters. And so if we go to its main page on creates IO, this is kind of where, this is like the PYPI of Rust, right? So it can tell me what the current version is. I can just copy this right here. We're going to go to our cargo file. This is where we declare which dependencies we want to use. So before we can ever use anything in this clap library, we have to define it in our dependencies first, okay? And so you'll notice a second ago when we compiled that, it compiled in 1.2 seconds. Great. Didn't have a lot to do. We didn't have any dependencies at that point. Now, if we compile it again, now it's going to start compiling a lot more libraries because we're using clap, and clap is has additional dependencies as well, right? So now we've started to build out a dependency tree. Again, it's not the fastest. The next thing we want to do is take a look at how we want to build this out. So let's create a new function real quick. And this new function will just be called, I don't know, let's call it just create app. And so within this function, we'll kind of set up our command line interface, okay? So within clap, there's a couple structs that we are going to deal with. One is an app. So this is kind of like the overall thing. And if we go here, we immediately see an example. So we can take this, we'll use it as a quick boilerplate. So we'll say for author, I don't know, deving DFIR, just for now, we'll say yet another EVTX tool. About custom interface for the Rust EVTX library. All right, I'm not going to worry about an argument quite yet. We're not going to worry about get matches. And I don't really care for this after help either. All right, so this is kind of our boilerplate. This function is going to give us an app struct, okay? And so over here, we'll say let app equal create app, okay? And this is going to throw an error that we need to import the app struct, and then it's basically going to give us help. Hey, try doing this kind of thing. And so that's really all we have to do. We say use this specific module from clap, right? All right, and then we have another error, and that's because our app struct has to have a lifetime parameter. So this is where you're going to start getting into a little bit of Rust specific things. And it's not a big deal. Like, you can watch tons of videos on this, but basically we are creating these static strings, and so when we define this new app struct, these strings have to live for the lifetime of app at least, and that's what this is right here. And we can even say, we'll just say static. So now everything will build properly. In fact, I think we can even say, let's build this real quick. And then now when we go to run our tool, we can say -h, maybe dash help negative. And I think that is because we need to add a help. Or maybe we just need to add an arg. So what we're going to do is we're going to say, in addition to app, we also want to use the arg struct, import that in, and we're going to define an argument real quick. So we'll say we'll make our variable name called arg underscore, let's say source, right? We have to have a source. And then if we look back over here, we can see some examples. So we'll say new source, and then let's go look at the documentation for an arg. All right, so short will be like a dash. So in this case, it would be like -c. Long would be like --config, right? So first we want to say short, and we want to be able to provide something to it just using -s. But if someone wants to use the long version of it, they can, and we'll just call that source. So the -s and source will be the exact same thing. And then we can say takes values, so they would have to supply a value to source, and that would be obviously the path to the EVTX file we want to parse, or a folder. And then you can even define like a value name. So value name will be kind of what shows up in the help. So we can say something like source, and then of course a help. So we can say something like the source of the EVTX file, or a folder of EVTX files. And we can make this recursive too, so it's not like it can only be one. I think for this one, we might have to do a single quote. Okay. All right, so now we have an argument. Now we want to append that argument to our app. So we're going to say, we're going to pass it that arg that we just created. So let's try building again. And then the reason we didn't, we have to say, let's say let options equal app dot get matches. That returns to us this arg matches struct. And when we do get matches, that's when it's actually parsing what the user provided to the application. And that's why I wasn't displaying a second ago. So let's rebuild this real quick, and then we'll say dash help. All right, so now we have kind of this whole command line looking thing built up around our custom interface. I just say, hey, this is 0001 or 001, and then that looks good. So the next step is to start implementing logic behind parsing, right? Because now we can give it a source, something to parse with. So we want to use part of the standard library has a path struct, much like Python has the pathlib. So std, and then we'll say path, and then we want to use the path struct from that. Even if you've been doing Python, or maybe you're wanting to learn Python, I recommend getting to know the standard lib path or pathlib that comes with Python now. You can just do a lot of path type functionality with a class rather than just dealing with path strings. But what we want to do here is we want to say let source equal, we'll say source string is equal to options dot get value. I think get value. Let's go back to our documents real quick. And we want to look at arg matches and look at the value, the options we want to say value of, not get value. So value of source, up here in create app, this is the name of our argument, and so that's what we call to get that value. So value of source. Now, you're not always guaranteed to have a value of something. So when you call a value of, it's an optional string, because maybe it's required, maybe it's not. So in Python, it would be a string or it would be none. But in Rust, it's just going to be an optional string. And so then what we're going to say is we expect source. And if we don't have source, we're going to throw an error and say no source param was provided. And it's that easy. All right. And if you notice up here, we can actually say, or here, if you want to see real quick, like if we build this and then we call our tool -s, and at this point we can give it anything. So I'm just going to give it current directory. Oh, I was expecting it to error out because we expect this to have a value. Oh, I'm sorry. So if we do this, so source exists, but there was no valid value provided to it, or even if we just call it by itself, no source was provided. I think this one errored out because source expected a value, and so that was clap saying, hey, you didn't even pass source a parameter, but you said -s. Yeah, so, but we can also just as easily say something like require. Required is true. So now we won't even be able to run this if we don't pass it a -s and give it a value. And that's what we want. So we now have a source string, but what we want to do is we want a source path from this string. So we can say something like, so we want path, and then we want new, and then we pass it this source string, and that's it. Now we have a path struct, and we can do a lot more with path than we can with a string. So if we say rust path, path. All right, so why I want to do this, and again, you look at the documentation, it shows you exactly how to use it, is because now instead of calling a bunch of different functions to find out if it's a directory, because it's in this struct, I can just say something like is dir, and that's it. And that's way more convenient than me building all this logic around statting the string and then finding out if it's a file or not. So I can say if source path dot, is file, else I can assume it's a folder, or I could say else if source path dot is directory. So remember, we want to be able to either pass this a file or we want to be able to pass this a folder. And then else we can just say e print line. So this will print a message to standard error. And we say the source provided is not a file or a directory, right? And then it would just exit out. All right, so now another cool thing that you can do is as you build something out, and I still want to compile the code, I can call a macro called unimplemented. And I can say something like file parsing has not been implemented yet, right? And then of course, and throw that down here too, and say dir parsing has not been implemented yet. So now if we compile this, we can then say something like -s, give it our root, and it's just going to panic out and crash and say dir parsing has not been implemented yet. That's because I passed it a dot. Just as easily I could pass it in any given file, like our cargo file, and it would say the same thing, file parsing has not been implemented yet. So that's good. All right, so now we can start working on building logic around our actual EVTX parsing, okay? So let's go look at our EVTX library. All right, so to start off with, we're just going to grab the current version, but in a minute, we'll upgrade that to the current version that's in Git and not on crates.io. And that's because there's some bugs that were fixed that I want to make sure gets accounted for, but it hasn't been released yet on crates.io. So that'll be good if you ever need to figure out how to use someone's fork or someone's library that's on GitHub, but is not in crates.io, meaning you can't just declare it this easily. I'll show you how to do that here in a bit. All right, so now we want to import our EVTX library. We're going to come up here. First, let's go ahead and kind of create a placeholder for our function. We're going to say function process file, and then we are going to do this. We're going to say path, and all right, I'm going to show you something fancy here. Instead of passing in something like a string, I don't like working with strings for paths. It's generally not the best idea to do. So instead, I want to say, I want to be able to pass this function anything that can be a path, right? A string can be a path, so I can pass this function a string. So I can say implement as ref, and I'm going to say it needs to be able to implement path as a reference. Okay, so now this is a cool trick to know about, because this means this function is much more dynamic than just being able to pass it like a given like struct. So like something like or type. So like even like it could be a string. It could be a string. It could be a reference string. It would take either one of those. And you'll see this, like if we go, this is why it's fun to just look over other people's code, because this is where I learned it. I didn't know about that, and it was kind of limiting. But then you go look at something like this, and we go look at EVTX parser, and then we can say something like from path, and you'll see the same syntax used in a lot of places. And that's because I don't know, like I shouldn't assume that you just magically have a string or a reference to a string. But if I do those things, it kind of limits what you can pass in, and I want it to be a little bit more dynamic than that. All right, so now we have a path that we're passing to our process file function. Let's go ahead and use the EVTX library now. The first thing we want to use is EVTX parser. This is kind of the core. And so we just looked at that too from path, right? So I can just directly pass in whatever I pass to this file into this thing, and it's just going to magically work. And that's exactly why we do this. So let parser equal this guy. And you notice here it's going to return us a result. So we want to handle this result. So instead of equaling, just the result from this function, which was from path, we want to say match, and then we want to say if it returns a good structure, like there was no errors, we just pass it on. So we'd call this and say P and return P. So then parser gets set to P essentially. But if we have an error that comes back, we'll set it to the variable E. Let's do something. We want to know about it. So we're going to say E print line, and then we want to say something like there was an error parsing, or there was an error creating a parser for, we can say file, and then after that we can give it the error message. So let's do this real quick. You notice it says implements as ref. So what we have here can be many different things, but it's guaranteed to always have a function called as ref. So path is equal to, we're just going to overwrite the variable as ref. And that's what gives us, now this is going to be a path. So we can still pass this in because it still implements path as reference. And then here we can also call it, so we want to say path, and a path cannot be printed out to console. And this is really good to know about. And this is also another reason why we would want to use the path struct over strings. For example, the Windows console cannot display all character codes. It can handle a lot more than it can print out. And so to handle that, what we want to do is print out whatever it can display to the console, right? So this is going to be different than if I'm running a WSL terminal. It's going to be different if I'm running a PowerShell window. It's going to be different if I'm running a CMD window. And so using displays and working with paths is much more accurate than dealing with strings that don't render correctly. And that's important to know about. All right, so, and you saw just a second ago, so we want to know that there's an error. We'd now show the path that errored out, creating a parser for it, and then what the error was, which is, we define that as E. It's going to throw an error because we want, this says, hey, I expected an EVTX parser and I got nothing because of this section. So in the case that it does error out, I just want to return from this function. I don't want to continue on anymore. And then for this syntax, because I'm setting a variable equal to something, we need to give it a semicolon here. All right, so this will compile now. And then we need to do something with this parser, right? So what we would do is, in this case, we're going to deal with JSON. If we go to here, let's go to EVTX parser, and then we go to, this is the function we're going to want to call. So records JSON value. This is going to create an iterator, parser. And we say for our result, so record result in our iterator. Let's do something. So again, this is going to error out because if we go look over here, when we call this function, we're passing in a mutable reference of the struct parser, and we did not make this struct mutable. So we say mute, let mute parser. All right, and so now it's going to be happy and let us compile. Okay, and so next, we want to be able to handle our result because it could error out while the library is trying to serialize the raw bytes from any given record. So again, we're going to say let entry, or we can say let record equal match. We're going to do the same thing we did up here and say, if you're okay, if everything was good when you got serialized, just pass the record through, and so record would become whatever's good. But if there's an error, set the error to the variable E, and let's again go ahead and output an error message to standard error, and we'll say there was an error serializing a record for the file, and then we'll go ahead and say what the error was. And then, so now there's kind of two errors that can occur here. There can be an error where we can't even create a parser for this file, something like it's not a valid event log. Or we can have errors while the parser is trying to serialize the raw binary XML. Okay, and then we'll want to do the same here. Instead of returning, we would say continue. And this is important. So whenever it hits an error, we want to know about it, but we also want to keep going too. And so this is another thing I want to highlight a little bit later. I don't know if it'll be a separate video or not, but if we compare the results to doing it this way versus the tool that comes with the EVTX library, we'll see a drastic difference in counts. And that's because I believe it's happening because the EVTX dump, which is the tool that comes with the library, isn't continuing. Instead of it's just kind of calling it quits. But I digress. We'll take a look at that later. All right, so now that we have a record, which is a serialized record, so this is effectively what we have now, there's a couple different things that we have. We can look at the event record ID, timestamp, and data. So data in this case, because we're using records JSON value, the record.data is going to be that JSON value. And so if we say something like, let's just say print line record.data, we serialize that as a string, like that's it. Now we have a means to actually process a file. Oh, if I spelled that correctly. All right, so now we have a means to process a file. So now we can go down here and say, okay, if it's a file, process that file, and that's it. Okay, so let's go ahead and compile real quick. All right, so now we're going to say target release. There's our help. Give it a source. All right, we need some EVTX files. Let's see, I copied some over, so I've got some ready for us. Let's just pass it this application log file, hit enter, and boom. All right, so there's all of our event logs for that one file, okay? Before we move on to implementing parsing from a directory, I want to include in this data, in the output, I want to include the source file. That's not a part of, what you get out from this parsed record, so we have to add it to it. So that means we have to add another library here. And this is kind of the standard JSON library that EVTX is using, and it's called, so Rust, CRD, JSON. And so we're going to use this one. And what version over here is 1059. So if we go to our toml, we'll say CRD JSON. Save that. All right. So now what we have to do, I'm going to say cargo build release real quick, just because now that we've added a new crate or a new dependency, is going to have to compile a couple more things. So then we say, so use CRD JSON, and we're going to use this JSON macro. It's going to make things easy for us, okay? And in order to do that, what we're going to do is we're going to say let mute, because remember we're going to tweak this data. We'll say value is equal to record.data. And then, or we can even say like JSON value, because that's what we're dealing with at this point. And then we're going to say JSON value. We'll just call this, like, let's say source file is equal to, so we need to say JSON, because now we have to set this attribute in the JSON value as another JSON like structure. Okay, and that's where this macro comes into play, is we can say, because like if we said something like just a file, this will actually fail because we can't set this key to a string. It has to be a JSON, a JSON enum. So, but if we just wrap it in this macro, that does everything for us, and we don't have to get crazy with it. So it's just magic. And then instead of this down here, we're going to say JSON value. All right, but of course we don't want this. We want path. All right, so if we say display like we did up there, it's not going to work because JSON, the macro doesn't know how to deserialize the display. So instead, we'll just say, I'm just going to do string to string lossy, and then any invalid characters will just get replaced. Cargo build. All right, so now if we rerun, obviously there's a lot of stuff here. Let's just copy one of these out real quick and take a look at what we have. All right, so now this is our event log structure, and then here is the attribute that we just added. So this is how we can kind of start augmenting and tweaking how we want our output to look. So the next thing we want to do is I want to add in some parser settings, and that's because I don't like the default setup that comes with the EVTX parser. So we need to do EVTX, or I think it's, parser settings. All right, and this will let us kind of tell the parser how we want it to act. So down here, I'm going to say let settings equal parser settings new. And then down here, when we pass it the parser, we can tell it the parser with, what is it? I'll go look at the docs real quick. EVTX, we look at our parser. Our parser, we have a function called with configuration, and that's what we want to use. So dot with configuration. Okay, and then now we can pass it the settings. Now, by default, when we call new, it's just going to call the default function. So we want to be able to tweak these a bit. And here's what I like to do. If we go to our settings, we can see the different things that we can set it to. We want to say, I want to separate JSON attributes, and this creates more consistent naming standard in the attributes produced. And we say true. Okay. And I think that's all I care. You can, we can even say get number of threads. So here in a second, when we implement directory parsing, we'll want to pass a thread option to it. And we can use this to also control how many threads we want the library to use. Okay, so, but for now, all I care about is separate JSON attributes, and we can take a look, like you see it here, like event attributes. Let's take a look at how this changes things. Let's recompile. Let's rerun. Kill you. I'll grab any old event here. All right, so the first one is before we added the separate JSON attributes. And so let's look at kind of how that affected things. So you see how there's event and then hashtag attributes here. Here it's event underscore attributes. And what this allows you to do is now here you see there's data and then there's a text. Anything with attributes is going to be put under this underscore attributes. And that drives much more consistency on where values get placed, which is much better if you're going to be ingesting this data into backends and querying and want to know that you're going to hit the correct attribute every single time. Because some days it might be event ID as the attribute. Some days it might be event ID dot hashtag text dot, meaning it's a nested value. Anyways, so something important to know about. And you'll see this a lot in other tools too that try and represent XML as JSON. You'll see these like hashtag and then name of the attribute kind of stuff. It's just one of those things where, JSON is not the same as XML. And so there's kind of different ways where you can represent some of the properties that are unique to XML that you can't necessarily reproduce in JSON. But I digress. Cool. So at this point, we've created a function to parse a file. We've created our EVTX parser. We've created settings for our parser and tweaked those to customize how we want our output to be. And then, of course, we've added additional values to what the library is giving us to help augment our data. So in this case, it's just the source file, right? But it could be many more things. All right, so let's take a look at implementing directory recursion. All right, we want to now switch over to our ignore crate. First things first, we want to add our ignore crate. Copy this over to our cargo toml file for dependency. So we want to add ignore. All right, now go back over here. And we can take a look. All right, so you instantly see right off the bat using this walk. But we want to use a WalkBuilder because we want to create a parallel walker. And so let's go ahead and import this guy. And then let's create a new placeholder function here. So process directory path implement as ref path. Okay. All right, so we'll say let WalkBuilder new, and then let's say let path equal path dot as ref. This makes things a little easier. All right, so we create a new WalkBuilder. Let's go take a look at that struct. There's a lot of things that you have to know about this. By default, it takes into account things like get ignore files, get excludes, hidden files, and so it kind of becomes important that whenever you go about using, libraries, you need to know something about that library and how to use it and kind of the quirks with it. By default, it sets a lot of these exclusions, and I don't want that. I just want everything included no matter what. And so there's a function called standard filters, and this is kind of like what's set by default, where you ignore hiddens, you ignore gets and exclude files. So I'm going to say build a walker or a WalkBuilder, and then standard filters is going to be false. Okay, and that kind of puts it where I want it. And then what we do once we set the settings we want, we can build parallel, and that gives us a walk parallel. Whereas in the examples you see is we're just using a walk, but we want to multi-thread this out. So we'll say dot build parallel, and then we'll say let walker equal. All right, so now we can start utilizing this one. So what happens is we are going to run like kind of like a new thread with this, and that's what's going to do the walking. So we say walker.run, and then this is what gets passed inside of this new thread. And there's generally most projects will kind of have like examples, right? So if we go to this project's examples, they have a good example of using this right here. And we can also pass the threads to it. Let's go ahead and do this real quick. Let's go back to our create app function where we define our parameters. Let's create a new function. We're going to say our new one will be, we're going to give it a new, we're going to give it a new argument, which is threads. Call it threads -t for short, -- threads for long, takes values, yes, and say number of threads. And then the number of threads we want to use. All right, and then we have to add this to our app, of course. So we come down here and say .arg, give it our new argument. Cool. So, I mean, that's as easy as it is to add a new parameter. And then the other thing we need to take into account is we need to be able to pass. We might want to pass these arguments to our functions. For example, maybe as we keep building stuff out, there's more and more stuff I want to pass on to process file and process directory. And so what we're going to do, I'm going to cancel this out real quick so we can compile. Let's pass our options to this function. So we'll do process file first, which is here, options, and if we come down here, we can see options is an arg matches. And so what we have to do is we're going to pass it a reference to those options. And by passing it a reference, we're going to be able to pass it between threads as well, as long as we never make any writes to that variable. Otherwise, Rust will say, hey, you're passing this variable between multiple threads and you're writing to it. This is very unsafe, which is exactly what Rust is not about. So, all right, so arg matches, we need to import this. So if we go back up to clap, say arg matches. All right, so now we can pass options. Because remember, we can also define how many threads we want here as well. But so everything that you pass in through, everything that the app parses is going to be a string. So we have to convert a string to an int, basically. And if we go to, let's go back to EVTX library. If we go to our options, parser settings, and we set number of threads, we need to pass it a usize, okay? So over here, we can say num threads, and then what we pass it has to be of type usize. All right, so then we can say we'll say let num of threads equal options dot value of threads. All right, and remember this is optional. So if we're going to say dot map or so the default is, so if this is none, we set it to 0. But if it's something, if it's a value, we need to convert that value to usize because it's going to be string. And so we can say, we do that with kind of creating these pipes here. So value will be the input of this function, and then we're going to say v.parse, and we're going to parse this as usize, okay? And that's it. And so what just happened, again, we need to parses the string. I believe we have to import, let's see, let me look at my notes real quick. Oh, that's because this can error out. Because maybe we pass in a string that's like hello. Well, hello isn't a usize, right? So we need to say, we'll just expect that this is valid. Otherwise, it's going to panic and say cannot parse threads thread count as usize. All right, so now that's good to go. And we'll throw that there. All right, so what we did, quick review, we have an optional string, and we say, hey, if you're none, we'll default to 0. But if you are something, we'll convert that something into a usize. And if that something can't be converted into a usize because it's not a string that represents a number, we'll error out of everything and just say cannot parse thread count as usize. All right, and then we can pass this to the parser settings for our EVTX parser. All right, that was fun. Now we'll add this as well over here. All right, so now when we go to build parallel, we can do the same thing, right? I'll just copy this over, come down here, say number of threads, and then now we can add what is it? Threads, number of threads from what we passed in. And it's that easy. So now when we go to walk our directory, we'll have that number of threads walking. All right. So now what we're going to do is we're going to pass this a function, okay? And it is going to take, let's see, we're going to have a box. And we're going to move a result into this function. And then we need to there we go. All right, so now it knows that result is a directory entry or it's going to be an error. And we can say continue. But first, we are going to do this. All right, so again, you can get the example, well, we can look at the function definition and see what goes in this, but more so, I don't necessarily 100% like recognize this easily. And it's best to just go look at examples and see how they do things. And we just basically did what was in the example right here. So we could have just copied and pasted this and worked off of that, right? In fact, we can do that. So within run, we just want this guy. And then we don't have a transmitter. Get rid of that. All right, so this is where we kind of want to start working from. All right, so when the walker is iterating a directory, it might error out on an entry for any given number of reasons. Maybe the entry is corrupt on disk, but it's something we still want to know about. So we're going to say, we're going to do the same thing we've done before and say let dir entry equal to match result. And then if it's okay, we'll just pass the entry. But if there's an error, we'll say e print line error reading a dir entry. And then we need to skip this, so we'll say return skip. All right, so by the way, these are included in this walk state. That's why we import it like this right here. And you put a semicolon here. But so if we go over to our documentation and we go to we can just go to walk state. Here it is. We can see that there's a continue, skip, and quit. So here we're returning continue, but if we hit this, we're gonna go ahead and skip the entry. All right, so now we have a DIR entry. So if we go back to here and we go to our structs, this is kind of all of the things we can get out of a directory entry. Path obviously being something we're interested in. So we can say something like let entry path equal dir entry dot path, and then now let's say we're only going to want to deal with anything with a certain extension, right? Like we only care about like .evtx files. So this is where we can start kind of filtering, everything we don't care about out. If we go to path, again, remember earlier we used is dir and is file. Now we want to use the extension function, which can return an optional string, an OS string. An OS string is different than a normal string. Again, this is why when we defined our functions, we want to implement as path and not use strings, because when you're dealing with paths, you want to deal with OS strings and not regular strings because of the encodings that can be associated. All right, so now we say if let sum equal entry path dot extension, and we can just call this ext, and if ext, by the way, real quick, so if our entry has an extension, we want to kind of do some logic. Otherwise, if it doesn't have an extension, we want to skip it anyways, right? We're not going to want to parse something that doesn't have a .evtx extension. So we would just say return skip anyhow. All right, so then here we would say if EVTX, and we'll say to string lossy dot, we want to convert it to lowercase to we want to say to string lossy and then to lowercase, and if this is equal to EVTX, or actually rather we'd say if it's not equal to EVTX, then we'll go ahead and return skip. Okay. Oh, ext. Yep, sorry, messed that one up. All right, so we have an extension and we want to convert this extension to a string and then make it lowercase and then compare that and say if it's not EVTX, then skip it. We don't care about it. All right, so by the time we hit here, we've kind of done this extension exclusion. So if it hits here, now we're like, all right, this is something we want to process, and now we can just call this other function that we already have, process file, and then we can pass it our path, and we can pass it options. Okay, and that's it. Now let's throw this down here. So we put in the logic earlier. If it's a file, use process file function. Now, if it's a directory, use process directory. And we're going to give it the exact same things: source path and options. Okay. All right. And that looks good. So now let's compile it. So we've got a couple extra things to compile that since we added the ignore module or library. All right, so let's go ahead and run this against our test folder. So earlier we passed it an individual file. Now we want to just pass it, a whole folder full of stuff. And then let's output the let's redirect the output into a file called EVTX output.json lines. Oh, and remember earlier I just copied and pasted this and left in the required. We don't necessarily need to require threads, right? Because if it's if we don't pass it threads, it's going to set it to 0. By the way, if you set something to 0 for threads, generally the library isn't going to make it not multi-threaded. It's going to set default threads, which is generally the number of logical processors that you have. So let's rebuild this real quick. Now that we removed the required property from the threads parameter. Rerun, and it's that fast. Let's take a look. Oh, we don't have anything. I must have made a mistake somewhere. What was it? What do you think it was? All right. If extension is not EVTX, skip it. I'll skip this. Why? Entry path. This all looks good. I don't think this should do it, but just in case. All right, now it's running. I don't know that I understand that. I'd have to take a closer look at it, but I didn't do it in my test, and my test worked that I did before I made this video. All right, but either way, now you see that there's a lot of data populated real quick. I like RIP grep, so I don't have it installed. So cargo install RIP grep. All right, so let's do this. All right, so we're gonna use RIP grep. We're going to say count the occurrences. So this effectively, using the double quotes like this, effectively means new line. So we're actually counting the new lines here. And then we're going to give it our output file, run it against that. So there was, 100,000 plus records that were parsed out from this tool. So let's look at another thing. I talked earlier about wanting to use the updated version of the library, but it's not in creates.io yet. So what we can do is just use the GitHub location and install from that instead of using creates.io. So what we will do is go to our cargo, and we're going to say dependencies.evtx, and then we're going to say git equals our git path. We're going to take this out. And then we're going to say, let's use branch equals master. All right. And now if we build this, I can't remember, we might have to specify the version when we use git from another, or when we use a git source instead of creates.io. But nope, never mind. It's working fine. All right. So that compiled. Let's just rerun real quick and see if there is a difference in output. Maybe there is, maybe there's not. But there were a couple bugs addressed lately that I want to have included. So if we go back here, rerun our same thing, so we get the same number of records, so that's fine. But now let's take a look at something else. So like I have a pull request in for being able to parse out empty pages. And this can kind of do some record recovery. So like if you wanted to, if there was a fork that you want to use, like this is how you can go about doing that. So instead of using this location, we'll use that location, and then there is a parse empty pages feature. So for branch, we want to use that. All right, so let's recompile real quick. All right, so with that, there's a couple new things that we would want to include into this, right? So now we are going to let's see. There's going to be a new setting that we want to enable, and that will be parse empty chunks. So if we go to our settings, now that we're using this different version, in addition to separate JSON attributes and number of threads, we also want to say parse empty chunks true. And so this is basically enabling a bit of carving. Now, it makes it take a little bit longer, but you're hardly going to notice it. But there's a little bit more overhead in carving out empty chunks too. So then we're going to, well, really we can reparse it now and see if we get any additional records out of this data set. So let's go back. This guy, rerun this. There's going to be some additional error messages now that we've added in carving, just because we're going to get some false positives on, hey, we think this is a record, but you know, it's just when you carve, you get some junk, right? And then if we rerun, so we now see that our parse count went up by a couple hundred, so that's good. All right, cool. So that's how you can use, you know, someone else's fork, use a feature you want to, you know, add in that's not included in the creates.io version. The other thing we want to do is it's changed up now. In addition to data, there is, if we go to record, there's a new attribute here called allocation. So this can tell us if an allocated is a record is allocated or recovered. And so we want to include that in our output, right? So now we can say JSON value allocation, let's say allocation flag, and that is equal to JSON. We'll say record dot allocation. Okay. So now, and I believe we have, there's a toString option. So this can be formatted as a string. So we can say, actually, I think we can just say dot toString. See if that works. Yep, that works. Okay, cool. All right, cool. So let's recompile this real quick. Rerun. And if we look over here, so we should have two different types of records, allocated records and empty page recovery records. So what we can do is we can say, all right, RIP grep max 1 count, and we're going to look for that flag. Here's an entry. Let's just take a look real quick. All right. And so now, sometimes you're going to get a little bit of junk with it. Again, this is carving. And we see that this is some recovery. So that gives you a good example of, yeah, just using different, Git repos, and it might not be implemented in a main branch or something, but let's see how many there are in here. We want to say count. So 245, and I think that lined up with our difference of records that we saw up there. Let's see. I imagine we'd have some good ones in here. Like, there's still a lot of good looking stuff in here. So yeah, cool. Hopefully this kind of gave you a good overview of how you can create an interface using Clap, how you can use the ignore crate to parallel iterate over files in a folder, and of course this is, recursive as well. And then look at, using different parsing utilities and using, forks. But I think we're going to leave it here. I think after this, what we'll do next is just do some different tool comparisons on this, because I've noticed a couple tools are missing some records, so I'd like to try and pinpoint what records are being missed by other tools, and then just kind of go through like how you can kind of narrow stuff down, because when you're dealing with a large amount of data like this, it can sometimes get a little frustrating and difficult to kind of nitpick, what's missing in one set versus another set. So, hope you enjoyed this video, and catch you next time.